I think it was specifically the 6th grade. I was in some elementary school, very relaxed. But my father was worried about my knowledge in mathematics. He decided to move me out of that school and try to get me back on track with a school of mathematics. And I failed the exam, entrance exam for the first time, which upset me very much. And I decided I would study mathematics more. So my parents got me books, a lot of problems, I tried to solve them. I felt I was getting better every day, and that was how I got hooked up with mathematics. The Langlands Programme is the extraordinary vision of Canadian mathematicians, the name Robert Langlands. Langlands had this extraordinary vision. He draw abstract but very large pictures, but there's a very precise relation between these different continents of mathematics. In addition to his vision, his conjectures, a lot of questions, he developed a strategy to solve these questions, to prove them. After long elaboration, and he reduced to some very specific identities, certain integral equal to others. Right? So that's what he called the fundamental lemma. He made a lot of calculation that give evidences for his conjectures, but he was not able to prove them in generalities. And many of his students and followers tried to solve them. When I was PhD students, and after that there's a new approach to Langlands Programme, the geometricization of the Langlands Programme. I was a part of that. From the very beginning, I was very interested to prove the fundamental lemma using this kind of geometric method. And my work was to discover these geometric structures, geometric shape that explain the fundamental lemma, and eventually that allowed me to prove it, and that is probably my best achievement or contribution to mathematics so far. And at some point, I remember vividly, I just came up with some very simple and basic thing about matrices, or some very elementary statement. But I was surprised that people didn't see it before, and with that, I could actually reformulate the whole problem of Langlands, fundamental lemma, in the whole new setting, which could become clearer. And actually, that allowed me to ask questions that Langlands couldn't ask, because he didn't have all this geometric shape and on these geometric structures in the game. I come to the age and I actually feel more happy in Asia, it's an Asian vibe. And for professional reasons, I start believing that Asia will be the futures, the centers of science and mathematics. And there's great opportunities to develop mathematics in China, in Asia, in border, and I really want to be a part of that development. I got 7 offers in different universities in Hong Kong, and they're all very good offers, but at the end I thought Hong Kong is probably the next chapters of our life. Yes. Hong Kong, you have a great department of mathematics. Some of my colleagues are really very well-known and world-class mathematicians. HKU leadership reassure me that they have ambition to grow the math department to become a world-class center of mathematics. And I'm really eager to be a part of that effort. I really want to develop more bonds, mathematical bond in Asia, across Asia. Hong Kong seems to be the best place to build up this kind of Asian vision of mathematics.